Next, we're going to take a look at graphing piecewise functions. And that requires us to graph each part within the specific interval. And so we're essentially going to be graphing multiple equations and combining them on the same line, making sure to jump from one equation to the next as we move through our domain. So we're going to go ahead and graph the same functions that we had above, starting with a. So we're looking at our function, and the first thing we're going to graph is 2x plus 3 when x is less than or equal to 0. So what we first need is we need values of x less than or equal to 0. So 0, -1, -2. So we need 2 points to form a line, and the third one's to make sure it's in the right spot. So let's do an xy table. So 0, -1, -2. And when we substitute them in, 0 for x, -1 for x, and -2 for x, we get the points 0, 3, -1, 1, and -2, -1. So we can plot those points. 0, 3, -1, 1, -2, -1. Now, this line starts at 0 on the domain and continues left forever. So we're not going to extend our line in both directions like we normally do. We're going to start it at 0 and only extend it to the negative direction. So this is the graph of 2x plus 3 such that x is greater or less than or equal to 0. And because the domain for this portion is from -infinity to 0. So that's the only part of that line we're going to graph. Now we're going to go ahead and graph the other half. Well, recall that the other half is -x minus 1 for all values of x greater than 0. So let's get some values of x greater than 0, such as 1, 2, and 3. So we'll make another xy chart using 1, 2, and 3. And when we plug them into our equation, 1 for x, 2 for x, and 3 for x, we get -2, -3, and -4. So we have these ordered pairs, 1, -2, 2, -3, and 3, -4. Notice I forgot to write these ordered pairs. Let me write those down real quick. So we can plot these points, 1, -2, 2, -3, and 3, -4. Now, this line, again, also will not go in every direction. It continues off to the right. But notice our domain starts at 0. So our line needs to actually go all the way up to 0, but not include 0. And so the way that we indicate that is we use an open circle at 0, and we need to extend the line up to 0, but do not include x equals 0. Because -x minus 1, none of the x values are ever going to be 0. They will go all the way up to 0 as close as we mathematically can. So we use an open circle to indicate that we go up to the point, but we do not include the point. And this is the graph for the line of -x minus 1 for the values of x such that x is greater than 0. And that's basically how we graph a piecewise function. You don't need to include all of this stuff here or here when you're drawing your graph. That's all that we would have. But I like to have these notes here for you to reference what each part is. Let's go ahead and Let's go ahead and graph our second piecewise function. So this one's in 3 parts. So recall that the first part was the graph of x squared minus 1 for values of x less than or equal to 0. So we'll start with our xy chart and some values less than or equal to 0, 0, negative 1, and 2. And when we evaluate those, we get the ordered pairs 0, negative 1, negative 1, 0, and negative 2, 3. So we'll go ahead and plot those points there. Negative 1, 0, and negative 2, 3. Now remember, this is a quadratic equation, so quadratic equations have the U shape. And so we kind of see that U shape forming here. And so we're going to continue that U shape. But again, it's only for values of x less than 0. And so if we went to the right, the U shape would continue in this direction. But we have to stop at 0. So we're only going to get this one-sided U shape, and it's going to be curved up this way. Let's see if I can draw that a little bit. Doesn't have to be perfect. As long as I can clearly see the points and the shape, then there shouldn't be an issue. Let's go ahead and graph the second part. Recall that the second part was the line 2x minus 1. So we have that up here, 2x minus 1, for values between 0 and 5. So for values of x that are greater than 0 but less than or equal to 5. So let's pick a couple numbers. We'll use our xy chart. Now it's a good idea to use the number 0, or I'm sorry, the number greater than that, we got 1. And then we could use any other number, but we also want to include 5 because it goes all the way to 5. And then just like with before, because of the going up to 0 part here, we'll need to do the same thing that we did here. We're going to have to extend our line to x equals 0. So we'll pick another number in the middle, maybe 2. 2 is a nice easy one. And if we evaluate all of these ordered pairs, we get 1, 1, 2, 3, and 5, 9. 1, 1, 2, 3, and 5, 9. Now 2x minus 1 is a linear equation, so it will be a straight line. And again, we need to go all the way up to 0, but not past 0. And because that's already a point that's on our line, we don't need to do an open circle. It's included in another part of the function. So we just have to extend up in this direction. And that line will go all the way up to the red point. And while our middle function does not include x equals 0, they overlap at that point. So it kind of picks up where it left off and creates a straight line. Now let's look at our last section. The last section was that f of x equals 3 for all values of x greater than 5. And so if we look at an xy chart, any value greater than 5, well, x has to be 3. Or I'm sorry, y has to be 3. And so we have our ordered pairs. And this is going to give us a horizontal line. So starting at 5, I don't know why I drew this with an arrow. This doesn't need an arrow because this stops at 5. So starting at 5, the y values now have to be 3. So we're going to have a point here, and here, and here. Those are some of the values that we found. And again, it's for values greater than 5. So we want the open circle as we pick up here and continue off to the right forever for our third section. And so our first section continues off to the left forever. Our middle section has definite endpoints. And then our right section will continue off forever. So if we look at each of these domains, piece by piece, we have everything from negative infinity to 0 inclusive. Then everything from 0 to 5, and then everything from 5 to infinity, and that those three combined include every single value within our domain.